On this installment of Physics with Mr. G, we will be talking about thermal energy, a topic that you've had in every single chemistry class since, you've started school. But we're going to put a little physics spin on it. Nothing too major, it's basically the same stuff, but, just a little different. So my goal is just going to have you explain molecular motion as it relates to thermal energy changes in terms of conduction, convection, and radiation. You'll be able to explain common examples such as ice and soda to show how the direction of energy flows. You'll be able to determine the heat capacity of a substance using mass, specific heat, and its temperature. I'm sure you already know how to do that. And you'll be able to differentiate between conduction, convection, and radiation. So we're going to talk about temperature and heat first, because there's a difference between temperature and heat. Temperature is the measurement of the average kinetic energy of the molecules in material. So we're talking about temp. There we go. It relates to the kinetic energy. So how fast these guys are moving, because remember, kinetic energy equals 1/2 mv squared. These guys got small mass, these little particles, but they have a large velocity. So it's going to supply a lot of kinetic energy. So that's what temperature is. Not to be confused with heat, because heat is the transfer of that kinetic energy from one material to another. So we're transferring the energy is the heat. The temperature is the actual measurement of that energy. So some more about the temperature. Temperature of a substance is the measure of the average kinetic energy of its particles, which we already said. Its SI unit is the Kelvin. We here in America use Fahrenheit because we're lazy. The rest of the world uses Celsius, which is a lot easier to convert to Kelvin. Converting Fahrenheit to Kelvin is a little more tricky. You have to convert to Celsius first and then to Kelvin. It's pretty lame. Other temperature scales. We already talked about Celsius and Fahrenheit. This one you might not have heard of, the Rankine scale. Celsius is to Kelvin as Fahrenheit is to Rankine. To use a little, simile or whatever you call that from your English classes. Converting between Celsius and Fahrenheit, here's the equation. You take whatever degree Fahrenheit you have, subtract 32 from it, multiply it by 5/9, and you end up with its Celsius temperature. And backwards, you just take your Celsius temperature, multiply by 9/5, add 32 to it. That's how you go back and forth between those. So heat is the thermal energy that flows from something at a higher temperature to something at a lower temperature. Makes sense. We want to go from hot to cold. The heat travels from the hot thing into the cold thing. Heat is a form of energy. And it's measured in joules. We've seen joules before. What else is measured in joules? We got work, our kinetic energy, potential energy. We already knew that. Work. So I bet you that heat and work are going to be related somehow. We'll get there eventually. So the flow of thermal energy from one object to another. So in this case, the coffee cup is hot. So it's going to transfer heat into your hand. So the flow follows this arrow. In this bottom picture, though, the ice cube is cold. So your hand transfers heat into that ice cube. So the arrow points that way. Heat always flows from warmer to cooler. So hot coffee to your hand, hand to the ice cube, not the other way around. Duh. So some of the kinetic and potential energies of all the particles in an object are what is described as its thermal energy. And an increase in an object's speed doesn't affect the random motion of its particles. So no matter how fast you're moving, it doesn't affect how fast your particles in your body are moving until you hit something. So therefore, it doesn't affect your thermal energy. So let's see, we have some particles here. Potential energy increases, so your separation of these particles is going to increase. Kinetic energy increases, your speed of these particles is going to increase. And all these molecules are going to move more faster, and they're going to start bouncing off each other, and they're going to cause some heat. because of friction. So as temperature increases, so does thermal energy because the kinetic energy of the particles increased. So we add some heat to all these particles, and it's going to make them start going crazy and moving all about. It's going to increase their energy because we increase the temperature. So even if the temperature doesn't change, the thermal energy in a more massive substance is higher because it has, because it's a total measure of energy. So if you have a big object and a small object, both made out of the same thing, this one is going to have more thermal energy because it's more massive. Because it's a total measure of energy. It has more particles, so it's going to have more energy. So it's got more particles in here. This guy's only got, a few. So there's three different types of thermal energy transfer. We have conduction, convection, boom, 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 and radiation. You've probably heard of these words before, but I'm willing to bet you get at least these two confused. So we're going to talk about conduction first. It's usually how energy is transferred in solid objects. So when we're talking about conduction, materials must be in direct contact with each other. So this pan's hot, your hand touches that hot pan, it's in direct contact with that, your hand's in direct contact with that handle. The energy that's going to be transferred to your hands is because of conduction. So it's got to be direct contact, got to be touching. So direct contact, conduction. Contact, conduction. That's how, if you have electric burners at your house, you put a pot right on top of it. That electric burner is in direct contact with your pot. Since it's in direct contact, we have conduction of heat, of thermal energy. Just another thing of conduction, the flame is in direct contact with this metal rod. The metal rod heats up. And since your fingers are touching the metal rod, your hand's going to heat up too because it's in direct contact with the metal rod right there. Now we're going to talk about convection, which also starts with con, so maybe that contact isn't a very good example. So transfer of thermal energy in liquids and gases, this is how this usually works. The matter actually moves from one place to another. So during convection, so when we're boiling water on a stove, the burner heats the pot. The pot heats the water. They're in direct contact. So that conduction here and conduction between the pot and the water. But the water itself heats itself up. The hot water travels upwards to where there's cooler water, and that cooler water comes back down. It's a big cycle. It convects, convection. It's also how rain clouds are formed. We have some hot air down here, cold air up here. The hot moisture wants to travel upwards so it's cooler, and it turns into condensation, which in turn forms clouds, and then it turns back into rain, it comes back into the earth. Big cycle. It's convecting all the time. And lastly, we have radiation. It's when energy is transferred by electromagnetic waves. And we'll talk about more in E&M waves next term. So the transferring energy through space, and you don't need any matter to do it. Perfect example, the sun. There's nothing in space. It's a complete vacuum, so there's nothing for the heat to travel through. But we still get the heat from the sun because of the radiation. It can travel through space. So here's an example of all of them together. So you can hold this pot over top of the flames, not directly in the flames, so it's not touching. So it's just the radiation from the flames heating the pot. So there's our radiation. Now we have conduction here because here between the hand and the handle. Your hand is touching the handle, so therefore it's going to get hot. It's in contact, conduction. And we already discussed how the water gets hotter at the bottom first, and that hot water moves up, the cold water comes down. It's like a big cycle. It's convection. And that's it. Quick and easy one.